Okay, let's learn about circular motion of that one. So basically, what is a circular motion? And so what that circular motion is, when you have the one of the object that is moving around a center point. So let's suppose this is the object that we have it, and that is moving around. So this is the motion direction that I'm showing to you. So this is the motion direction at this point when going to come, and the motion direction is like this. So because this, let's suppose this is the ball. So to take the turn to this ball, so in which direction I had to apply the force? So what will be the condition so that it will move it in a circular path? In which direction? So is it had to apply the force in this direction? Is it this in which direction I had to actually apply the force to take the to follow that circular path? Here something, it goes in a circular path. What do you think about this? Okay, so let's look into that demonstration. So condition for a uniform circular motion. So let's suppose that right now we have, this is the red arrow that is showing the force direction. So the force is applied in this direction, and the blue arrow is the motion. So it is thinking like this, the object is already moving. So this is the object that you are applying the force in this direction, and this is the blue arrow that they represented in this one. This is the basically the motion is already happening. Just thinking like this, the car is already moving in this direction, and you are applying the force is also in this direction. In which direction the this car will, or the block will move? So it is going to be follow this path, correct? It goes to be go straight forward. So let me show you. So let me show to you. So as it goes in the straight path, correct? So simple, because the force and the motion direction both are in the same direction. Let's suppose that I make it 40 degree something to the, this is 40 degree that I taken the angle between the motion direction and the force direction. So in which direction it is going to be moved right now? So it is going to be follow some kind of the, could you feel that some kind of the motion like this? So let's check it out. So it is going to be follow this one. So it is going to be follow some kind of the motion like this something. So it is taking the curve something, if you look at this carefully. And now let's suppose that I increase the angle. As I increase this angle, so between them, so what is going to be happen is now is, so let me show to you, it will follow some kind of this path. Could you feel that when I'm going to make it 80, and the force is always at 80 degree to the motion, and the magic will happen at the 90 degree? Could you predict that what is going to happen? So now as you have the motion direction, this is the motion direction, you have it. This is a very interesting case. This is the motion direction, and this is the force direction. Force you are applying always 90 degree to the motion. So this is the force direction, and if I click on this, let's look into that. So now look at this carefully. Now always, what is the angle between them? Angle between the force that is acting, the red arrow is the force that is acting, the force that is acting toward the center. By the way, we call it that is centripetal force. We will come to that point. So at this point, look at the same thing. So the force is always towards the center. This force, we call it centripetal force, that is going to act along that. So this is a center point. About a center point, the force is acting. So what is the condition to have a uniform circular motion? The force that you exert on something that is moving, let's suppose that something is moving like this, so you had to apply 90 degree to that always when it is going to be take the turn like this. So it always you have to apply the 90 degree to the motion. So this is centripetal force that is acting toward the center. So that is the condition to have a uniform circular motion. So the force have to be always acted toward the center of that. So let me demonstrate that with the multiple example to have that one. Okay, let me make it slow of that. So let's look into that. So as the ball take the round and you are moving it like this, so can you guess this one who is providing the centripetal force here? What is the force that act in the string? Tension force. This is a tension force that is always perpendicular to the motion. Motion direction is inside the screen, by the way. So this is the motion direction. The motion is into the screen at this point. So it is going into, and the tension force is this one. So this is always 90-degree to the motion direction. This is the tension force right now that is acting towards the center of the rotation of the object. This is, we call it a centripetal force. Right? With this demonstration, and let me show you. So I'm going to shoot you also, but by the thing is, let's suppose as I shoot this, so let's suppose at this point it is here, and so as I shoot it, it is at this point here, and this is the center of the earth. Which force is responsible? So this force, gravitational force. So that gravitational force. This is a gravitational force that is basically acting. This is centripetal. FC I'm writing for the centripetal. Who is providing the necessary centripetal force here? Gravitational force. So the gravitational force is centripetal force that is acting. That is going to be take the turn. So if I try to show to you, I do it first, and so I shoot it. We'll check. This is how the satellite revolves or something. Let me show that demonstration also. But this is a simple demonstration. So that the gravity is pulling it and it is taking the because it is already in motion. As it is moving, it will fall down. It is not going to move by it. So it is going to be fall down. And let me show you the few of the interesting cases. Let's check it out this one. So as let me show you this one. So let me show you the forces that so that you can get an idea. So this is the gravitational force between the moon and the earth that is pulling it toward the center. Okay, so what I'm going to do is, let's suppose that I provide the sun. If I throw with the sun not that much sufficient velocity, is going to be fall down because it do not have that necessary force or centripetal force. I will come to that point. So to take the turn, so if I throw it with that, okay, so now this is how actually happened. So the thing is, right now if you look into that, so there is a force that is acting toward the center every time. So that is the force that is acting toward the center of that. And look at the motion at the, let's suppose at this moon is at this position, the motion direction is like this is the motion direction, and this is the force direction, that the gravitational force. So in this case, gravitational force is providing necessary centripetal force, centripetal center seeking force, basically, that is act toward the center. So centripetal force is the net force toward the center. Net force, I'm saying net force toward the center. So that is the case that we have it. So uh, let me, so this is the condition to be have that one. So it is always have to be 90 degrees. This is, let's suppose this is any of the two bodies taking due to the gravitational force. Let's suppose this is the moon, this is the earth, for the simplicity, but the ratio of the masses right now is 1 by 10th only. But the sun mass is almost 99 percent of the whole solar system. It is too heavy as comparison to the other planets. So this is the case that we have it. So if let's suppose I make it, the difference is more small. So now as there is a speed, that is angle, okay, so let me run it, and as I run it, you can see this is actually how the planet revolve around the sun. So there is a motion. Look at the motion direction. The force direction is always 90 degree to that, and this is that that gravitational force is pulling it inward. This is how you can think like this. This is a satellite that is revolving around the earth. So if I to show you the top view, there is an option of the top view. So there is an option of the top view, and if I show you the top view, that one you can think it like this. This is a satellite taking the round around the earth, and you can think it like this: the moon taking the round around the earth, or the other planet revolving around that, because of gravitational force that is seeking, so that is attracting toward the center. So the force of the action always have to be perpendicular to the motion of that one. So this is the bare minimum condition that you have to put it to have a circular motion, otherwise the circular motion is not going to be take place. Okay, so this is the hydrogen atom. So this is the, what is the charge on the, this is a nucleus. On the nucleus, what is the charge is proton, because of the proton positive charges. So is inside the nucleus, and this is the electron is revolving around that. So if now somebody asks you what is the force, which force is responsible to drag it inward, just think it like this: it is taking the circular round around that. So who is responsible to provide the centripetal? Let's put the electron is here. So let me make it the electron is here. Always the electron is get attracted towards the proton. What is the name of that force? Just leave it the comment. This is electron get towards the positive charge, as we know that the positive charge is going to be attracted that one. This force we call it electrostatic force. Electrostatic force, that is provide the necessary centripetal force here, that dragging the electron toward the center. We will discuss it. Let me end this one right now. The question is, if the force is acting towards the center, why the electron couldn't able to fall it, or the gravity or the earth pull is attracting the moon continuously, why the moon doesn't fall on the earth then? So it is only the force that is acting towards the gravity, why couldn't able to pull it down? So that's very interesting case. So leave the comment in the this one, and let me discuss it in the next.